Okay, picture this. Your organization is about to flip the switch on a powerful new enterprise AI. It's exciting, it's transformative, right? But it also opens up a whole new can of worms when it comes to risk. So let's dive right in and build a clear, actionable playbook for securing these incredibly complex new systems, and we'll use a real-world scenario to guide us the whole way.
So let's imagine we're all working for a company called Automate Corporation. And our new AI, well, it's basically the new central nervous system of the company. It's ingesting all our internal documents, our databases, even analyzing emails to help staff. On top of that, it's interacting directly with our customers. It's built for one thing: maximum efficiency.
And that is a billion-dollar question, isn't it? All that power creates brand new vulnerabilities that traditional cybersecurity just, well, it completely misses them. We're talking about a whole new class of threats here. Things like prompt injection, data poisoning, model theft. These aren't your typical software bugs. Nope. These are attacks on the very logic and learning process of the AI itself.
So, to protect our new AI, we really have to get our heads around this new threat landscape. We've got to look beyond the usual firewalls and access controls and start thinking about how the AI learns, how it reasons, and how it acts, because you can bet that's exactly where attackers are going to strike.
Let me put it this way. For years, we've all worried about things like SQL injection, where an attacker tricks a database into spilling its guts. Well, now we have prompt injection, where an attacker tricks the AI model directly. It's a similar concept, for sure. You're manipulating inputs to cause some really bad unintended actions, but the target and the techniques, that's a whole new ballgame. So where on earth do we even start? A fantastic place is the Open Worldwide Application Security Project, or OWASP. They give us 3 different lenses, think of them like layers of an onion, to help us systematically find and fix the vulnerabilities in our AI system. Let's peel them back one by one.
All right, the first layer, this is familiar territory. It's the classic OWASP Top 10. This helps us lock down everything around the AI. We're talking about the wrapper, the web interfaces, the APIs, the admin consoles, all the usual suspects. We still have to worry about broken access control or security misconfigurations here. For instance, what if an external customer somehow gets access to internal company data? That's this layer.
Okay, now for the next layer. This is where it gets interesting. The OWASP LLM Top 10. This one focuses specifically on the risks in large language model applications. For our company, Automate Corporation, this covers that customer-facing chatbot, the internal Q&A system for employees, and basically anywhere a human is talking directly to the AI.
And this is where these threats get really tangible. I mean, a customer could use prompt injection to trick the AI into exporting a bunch of invoices it shouldn't have access to. Or, with something like insecure output handling, the AI could just hallucinate a command and delete a critical record. And sensitive information disclosure? Oh boy, that's when the AI accidentally leaks, say, payroll data it picked up from an internal document it was trained on. These are direct attacks on the AI's ability to have a conversation.
The third and final OWASP lens covers the machine learning models that are working silently behind the scenes. These are the unsung heroes, right? The fraud detectors, the spam filters, the data classifiers. They don't chat with anyone, but they are just as vulnerable to nasty stuff like data poisoning, where an attacker slowly, methodically teaches the model to misclassify transactions. Or model evasion, where a cleverly crafted email just waltzes right past the spam filter.
Okay, OWASP gives us this fantastic, super detailed view of technical vulnerabilities. But to build a truly robust defense, we need to zoom out. We need tools that help us map these specific bugs to bigger business risks, and crucially, understand how a real-world attacker would actually operate. So let's move on to the next set of tools that help us do exactly that. And this is where the MIT AI Risk Repository comes in. This thing is a massive, curated database of over 1,000 documented AI incidents from the real world. It helps us think beyond just security bugs and start considering operational risks, privacy risks, and even socio-technical risks.
And this chart illustrates the point perfectly. See, security is just one piece of the pie. The repository forces us to ask some really tough questions. Questions about automation bias, like what happens when our staff blindly trust a wrong decision from the AI? Or governance risks, like who exactly is accountable when the AI messes up. It's a crucial step in understanding the full, real-world impact.
Now that we understand the broad risks, it's time to put on our black hats. And for that, we have MITRE ATLAS. If you're familiar with the famous ATT&C framework for traditional cybersecurity, well, this is its AI-focused cousin.
Atlas is a knowledge base of adversarial tactics and techniques built specifically to target AI systems. It literally lets us think like the attacker. So let's walk through a potential attack on our Automate Corporation using Atlas as our guide. First, the attacker uses data poisoning, injecting malicious records into the application logs that our AI analyzes. Next, they use model evasion to craft a transaction that our now compromised model fails to flag as fraud. And for the final blow, they use model inversion to analyze the AI's outputs and start extracting sensitive customer data that was in the original training set. See? Atlas makes the threat feel real and tactical.
So we have all these incredible tools and frameworks, right? But how do we turn all this knowledge into a repeatable, formal process? The final piece of this puzzle is integrating these new AI-specific concepts into the security programs we already have running. A huge part of this formalization is creating a common language. And that's exactly what the CVE AI Working Group is doing. By defining what actually counts as an AI vulnerability, they're making it possible to track and patch AI flaws, like a prompt injection bug in a popular open-source framework, just like we do for any other piece of software. This connects our new AI threat model directly to our existing vulnerability management pipeline. It's a game changer.
So the crucial point here is seeing how all these pieces fit together. You've got to think of it like a cohesive stack. At the very top, for overall governance, you have something like the NIST AI Risk Management Framework. Then you layer on MITRE ATLAS to adopt that attacker's perspective. For the systematic, nitty-gritty analysis, you use a method like STRIDE for AI. You also have to consider the AI supply chain with ISO standards to manage those third-party risks. And finally, down at the implementation level, you use the OWASP's top 10s as your practical, hands-on checklist. Let's make this really concrete with a quick example. Take the classic STRIDE framework, which many of us already use. We can just extend it for AI. Tampering is no longer just about changing a file on a server, now it's about data poisoning. Elevation of privilege isn't just a user gaining admin rights anymore, it's a prompt injection attack that tricks the AI into calling a high-privileged tool it should never touch. By mapping these old concepts to new threats, we can seamlessly integrate AI into the threat modeling workshops we're already running. So, after exploring all these different frameworks and tools, what's the playbook? What's the bottom line? It's all about bringing everything together into one unified, layered strategy that protects the AI from every possible angle. Here it is, the key takeaway, boiled down to 3 steps. First, you use those 3 OWASP lenses to identify specific vulnerabilities in the application wrapper, the LLM, and the backend ML models. Second, you use MIT's repository and MITRE ATLAS to map those vulnerabilities to broader business risks and real-world attack paths. And third, you integrate all of this into a formal process using that stacked framework we talked about, NIST, STRIDE, ISO, the whole shebang. This playbook gives us a really powerful defense for the threats we're facing today. But let's be honest, this landscape is evolving at an absolutely incredible speed. The real challenge, and the question we have to keep asking ourselves, is this: how do we build systems that are resilient not just to the attacks we know about, but to the ones that are still just over the horizon?